NASA launches a rocket at t equals 0 seconds. Its height in meters above sea level as a function of time is given by h of t equals negative 4.9 t squared plus 277 t plus 108. How long does it take until the rocket reaches its maximum height? What is the maximum height? And then finally, assuming that the rocket will splash down into the ocean, how long will it take for the splashdown to occur? Let's first take a look at this graphically. Here we see the graph of the height function in Desmos. Recall to adjust the window, which I've already done, we click on the wrench in the upper right hand corner and adjust the x and y axes, or horizontal and vertical axes here. We can also zoom in and zoom out by using the plus or minus. But again, I've already adjusted the window. To find the time of the maximum height and the maximum height, we would have to determine the ordered pair for the vertex, this point here. Then to determine the time at which the rocket splashes down into the ocean, we need to determine the t-intercept here on the right. Let's go back and calculate these, and then we'll come back to the graph and verify our answers. Recall when we have f of x equals ax squared plus bx plus c, the vertex is the ordered pair negative b divided by 2a, comma f of negative b divided by 2a. Of course, in our case, we have h of t, not f of x, but we can use the same formula. To begin analyzing the height function, notice a is equal to negative 4.9, b equals 277, and c equals 108. So for the first question, how long does it take until the rocket reaches its maximum height? We need to determine the t-coordinate of the vertex, which is given by t equals negative b divided by 2a, where b is 277 and a is negative 4.9. Simplifying, we have t equals 277 divided by 9.8, which is approximately 28.27 seconds. And now to determine the maximum height, or the height at the vertex, we need to evaluate the height function at t equals 277 divided by 9.8. I'm not going to use 28.27 because this is rounded. When using a rounded value, we'll have more of an error. So the maximum height is given by h of 277 divided by 9.8, which indicates we substitute this quotient for t into the original function, which gives us h of 277 divided by 9.8 equals negative 4.9 divided by the square of 277 divided by 9.8 plus 277 times 277 divided by 9.8 plus 108. This comes out to approximately 4,022.74 meters, which is the maximum height. And then finally, assuming the rocket will splash down into the ocean, how long will it take for the splash to occur? To answer this question, we set h of t, the height, equal to 0, and then solve the resulting equation. Replacing h of t with 0, we have the equation 0 equals negative 4.9 t squared plus 277 t plus 108. This is not factorable. We'll have to use the quadratic formula shown here below, where instead of x, of course, we have t. And therefore here we have t equals negative b, which is negative 277, plus or minus the square root of b squared, which gives us a square of 277 minus 4ac, which is minus 4 times negative 4.9 times 108. All of this is divided by 2 times a, which in our case is 2 times negative 4.9. Next we simplify. This gives us negative 277 plus or minus the square root of 78,845.8, all divided by negative 9.8. Notice this will give us two values, one when we use addition and another when we use subtraction. But of course we know time can't be negative, so we can throw out t sub 1 is approximately negative 0.39 and use t sub 2, which is approximately 56.92 seconds. Which means we now know the rocket will splash down in approximately 56.92 seconds. Let's go back to the graph and verify these results. The nice thing about Desmos is it's very easy to determine the key points on a graph. If I click on the graph, notice gray points appear at important points on the graph. We can click on the vertex and the ordered pair appears. Notice the t-value at the vertex is approximately 28.27 seconds, which we found for the time at which the rocket reaches its maximum height. And then the second value of approximately 4,022.74 gives us the approximate maximum height. And notice the graph does have two t-intercepts. We did find both. One of approximately negative 0.39, which in our case doesn't make sense because this is time, and then the one on the right is the time when the rocket splashes into the ocean, which verifies our answer of approximately 56.92 seconds. I hope you found this helpful.